What's up with it, my little fiddlers? Today we're coming back at you with another level 2 tutorial. We're dropping it in your feed like an egg on Easter. And like the egg on Easter, you're gonna love it. And it's filled with chocolate and...
Oh yeah, you can definitely tell it's recording because it tells you when it peaks.
Scout, this may be your hardest test yet. You're gonna have to reach inside your tool belt and not inside, probably outside, and grab the tools of knowledge.
So today you will be building a custom robot to conquer.
Shout out to Swiss Cheese Man Hands for slicking up this rig for us. Your robot can be literally whatever you want. It just has to be able to navigate through the maze, and it has to have an ultrasonic sensor mounted on the front to help it navigate. More on that in a second. Yay! Now, an important note. Fam, when you reach level 5, there will be no more follow-along tutorials. Just a challenge. Robot building materials. And the internet. That is the kernel of robotics. You build something, no part of it works. You attack it again and again and again. You cry, sweat, bleed for this thing. And when it finally works after years and years, no, probably not years, after a long time, it's the best feeling in the world. This project is gonna help you prepare for that. We want this to be like the big leagues so that you determine your destiny.
Speaking of skills.
Those skills. Ooh. Okay, now before you start planning, there are a few things that you should know that are gonna help your build function better. I'm gonna try to do this real quick.
Drop it again!
Turning scrub. Turning scrub is friction that's generated from your robot wheels dragging sideways when your robot's turning. Just keep in mind that if you're wheelbase, that's the distance between the wheels on your drivetrain, is longer than it is wide, you will have more turning scrub. Unless you use omnis. Next thing, gear ratios. There are two types of gears. Driving gears, aka the gear directly on the input. In this case, the input is the shaft of the motor. And driven gears, aka the gear connected to the output. In this case, the wheels. Now the important thing to remember is this. If the driving gear is bigger than the driven gear, your robot will have more speed, but less torque. Torque is like rotational force. If your driving gear is smaller than the driven gear, you will have less speed, but more torque. For this project, it's all a matter of what kind of powers you want your robot to possess. Is it faster or stronger? The gear ratio is a mathematical expression that compares the number of teeth your driving gear has to the number of teeth your driven gear has. Like this one has a 12 to 36 gear ratio. Tuck that one away for later, fam. We'll need it. One last thing to remember is to properly support your motor shaft, whether you be building your drivetrain or any part of your robot. For heaven's sakes, don't do this or this. Do this and this. Can you give me that? Helpful links will be in the description. One more thing, feel free to sketch out your build before you do it. I highly recommend. 10 out of 10, sketch again. Boom,
Yes,
do it.
and even if your build doesn't end up like how you sketched it, that's fine. It's just nice to have like a reference in case you want to do something specific.
Thank you, I'm so articulate.
So we can start with building the drivetrain. Make it however you want. As you can see, some of us decided to go with a more basic concept. I'd like to say that Parker wrote this script. I do not bully myself on a regular basis. So now let's mount the ultrasonic sensor. What is it, you ask? Well, ultrasonic sensors can tell how far away an object is. They send out these little clicks that are too high of a frequency for humans to hear, and then they time how long it takes the sound waves to bounce back from whatever's in front of them, and they use that to determine how far away the object in front of them is.
Make sure everything's hooked up and then let's go code! Woo! Here's how this is gonna roll. I'm gonna show you my strategy for solving the maze, and then I'm gonna give you a few code components that you can use, but it's gonna be you ultimately figuring out how the code fits together. It's like a puzzle in a Nancy Drew game, unless you wanna cheat. I'll show you how to cheat in a second. Be responsible, kids. If you want to try taking a stab at it without seeing my strategy and just coming up with your own strategy for solving the maze and making your own code for it, do it! Your challenge is to create code in ModKit to navigate your robot through Angelhorse maze. Here's my approach to the challenge. So, my robot, rightfully named Shoop, is going to drive forward, constantly using the ultrasonic sensor to measure the distance that they're away from the wall. When the distance becomes less than a certain amount, he's going to stop, he's going to check left or right, either one first is fine. And if he turns left and there is a wall there, he's going to turn all the way back to the right to check if there's a wall on his other side. If there is, he's gonna go back the way he came. At any point after any turn, there's no wall there, he's just gonna go forward in that direction, because that means that he's getting closer to solving the maze, my friend. Okay, I'll show you the building blocks to get started with implementing the strategy into your code. So in ModKit, I'm gonna need a drivetrain and an ultrasonic sensor, and I'm gonna assign my ports. Okay, and then go ahead and open up the settings for your drivetrain and edit the settings so that they fit your custom build. You can edit the motor layout, basically if your motors are in the front or the back of your robot, or if you're using 4 motors on your robot. Be sure to measure your wheelbase, that's the center of your wheel to the center of your wheel, and enter it in millimeters. Hint, you can measure in centimeters and multiply it by 10. Also enter the track, which is the middle of tire to middle of tire. And then you're gonna enter your gear ratio. Greta's gear ratio is 36 to 36, or 1 to 1, so I'm gonna keep that the same. So here's the basic structure for my code. I'm gonna, of course, when start, it's a basic, and I'm gonna put a forever loop, so that the sensor's constantly checking to see if there's something in front of it. Okay, now let's think about this. There are 4 kind of scenarios that we're approaching in this code. So if the sensor senses a wall in front of it, if it senses a wall after it's turned left, if it senses a wall after it's turned right, and if it senses no wall. So I'm going to drag some conditionals in there. Now all of our scenarios are covered. 1, 2, 3, or 4. We have 4 places in those conditionals. Here's a little sample piece of code for the ultrasonic sensor. It's the purple and green part. Basically, if the distance that your sensor measures is less than a desired amount, do whatever is in here. Really important to remember, your code works from the top down and the outside in. So it'll check if this first if statement is true first. It'll just keep looking for that, is the first one true, is the first one true, is the first one true. If it is true, it'll complete whatever action's in there, and then it will check if the next one's true, and so on. Let's say that we're running our code, and the first if statement's true, second one's true, and then it gets down to the third one and it's false. It'll exit all the if statements, and it'll just keep running through the loop again, waiting for that first if statement to be true. Remember that while that first if statement is not true, your robot's gonna do whatever's in the else. So it'll check if this one's true. If it is, it'll do the action that comes down here, and then check if that one's true. If it is, it'll do the action, and then check if that one's true. If it is, it'll do the action. If not, it'll do what's in the else. That should be all the clues you need to build out your code. Remember that you can do your own thing too, and if you're stuck, skip to the end of the video for a cheat sheet. Make adjustments to things like how far away from the wall your bot is when it stops, or how far it turns, until it can totally conquer Angelhorse Maze